Welcome, everyone, and thanks for joining us today. My name's Tim Farrar. I'm president of TMF Associates, which is a consulting and research firm based in Silicon Valley. We specialize in satellite and spectrum issues, and I've worked on broadband satellite systems for the last 25 years, dating back to the days of Teledesic. So I'm very pleased to moderate this GVF webinar in association with Connectivity Business News. We have got three great panelists here today. Unfortunately, the fourth panelist, Jeremy Turpin of Isotropic Systems, wasn't able to join us, but we have three great panelists for a very interesting discussion on innovation and the ground segment. The three panelists are Darren Bigley, the owner and vice president of Satellite Technologies, Sean Yarborough, the vice president of product management at ST Engineering iDirect, and finally, Todd Brown, Director of Business Development at AVL Technologies. I'm going to let each of those panelists introduce themselves individually before we get started and talk a little bit about their role and what their company does. So let's start with Darren.
Yes, okay, thanks a lot. I'm glad to be here. My name is Darren Bigley. I'm an owner of Satellite Technologies. We manufacture portable satellite communication antennas. So this is a very interesting discussion for us because we're constantly in a state of change here as the LEO, MEO orbits start taking precedence. So we're here to try to see what we can do to bring innovation to the ground segment.
Thanks very much. Sean, do you want to talk about ST Engineering iDirect?
Absolutely. So morning, everyone. So I'm Sean Yarborough from STE iDirect. We are a ground infrastructure provider. So we provide the entire ground infrastructure in terms of modems, processing nodes at the teleports, and then also the baseband processing. So if you're familiar with platforms such as our Dialog, Evolution, and Velocity platforms, those are some of the solutions we deliver to the market to help our partners, antenna manufacturers, providers, and the like, deliver those mobility and fixed services to end users. And so we're excited to talk about some of the things that we're doing today to accelerate the innovation, as Darren said earlier.
Great. And Todd, AVL Technologies.
Hi, as Tim just said, my name is Todd Brown. I'm the Director of Business Development at AVL Technologies. Joined the company about a year ago. Previous to that, I worked for the Department of Defense for about 25 years doing terminal development, implementation, programming, and then getting that into architectures and then architecture development and implementation. At AVL, same thing. As the industry's been changing, as new constellations are coming out, we traditionally did stow and go flyaways, anything from 4, 6 to 60 meters, and we're starting to move in more into the COTM and the ESA realm, right? Because we have to keep our terminals and antennas compatible with the new architectures that are coming out. So just, privileged to be here today and have a good conversation about how the industry is changing and what we need to do as partners going forward.
Thanks, everyone. I think it's a very good time to have a discussion on ground segment. It's a really interesting time in the satellite industry at the moment. We're hearing so much about all the new technologies, but often the prevailing sentiment in the satellite industry has been that the space segment's the most critical and most exciting part of the business. Spectacle of launches attracts most of the attention. That's what people write up in the paper. But none of that's any use for the end customer without a ground segment of gateways, terminals, backhaul, and software to tie it all together. However, it's usually been the case that the ground segment's a bit of an afterthought because the operators are focused on building the biggest and most capable satellites they can. And often the choice of ground segment technology has been made completely independently of the satellite design. Over the last decade, some operators such as Viasat have made the case that we do need an integrated space and ground network to produce the most capacity at the lowest cost. But it's still been challenging to build scale for that sort of vision until very recently. But now we've got two LEO operators, Starlink and Project Kuiper, who are laser focused on designing and building low-cost terminals for a mass consumer market. That means they need satellites optimized to work with the terminal design rather than the other way around. And in the case of Starlink, they've even decided to lower the altitude of their satellites to make the terminals cheap enough for consumers to afford and workable for self-installation. That's been the sort of primary design driver of the entire system, and I think Amazon is adopting much the same approach. However, in other parts of the satellite market outside of the consumer segment, a different approach may be needed. Some end users, particularly defense and mobility customers, need a robust multi-orbit infrastructure combining LEO, MEO, and GEO capacity together. And that requires new, more flexible terminals and software to tie it together. It may require integration with terrestrial networks and cloud services and standardization work to interoperate with 5G. And it certainly requires much greater efficiency to improve the price-performance ratio for satellite capacity. But above all, the whole satellite industry now has to cope with the increasing and very novel challenge that Starlink and Kuiper represent. So for the next hour or so, our panelists are going to discuss what innovations are emerging in the ground segment and how they're positioned to help the rest of the satellite industry address this looming threat. So let's get started. I started by mentioning end users that require a multi-orbit solution. So let's start by talking a little bit about who are the most important customers there and what are the key priorities for their terminals. Todd, you've come from the DoD. Do you want to talk about the government side in particular?
Yeah, I am a little bit biased there, right? And even at the company I work at now, we do a lot of our business with the government, but I would say it's the government as a whole, right? So there's different customers within the government that I think that need that. And I wouldn't say it's really multi-orbit. I would say it's assured conductivity, right? And that assured conductivity can be realized by using multiple orbits. And I think that's your military. I think it's your first responders, whether that's state, local, federal, right? So disaster relief, firefighting, big thing, as the season starts up, they have to have that connectivity. I think they're probably the most important customer that we have. And there's a reason that they can do that. And that's because it's very hard for certain individuals to have the funding to have multiple orbits standing by ready to go at any time that they need that. And that takes some financial backing that allows that to happen, right? So of course, the government is one of the places that you can look at that will pay for that to have that assured connectivity.
Yeah, Darren, do you want to expand a little on some of the terminal developments and the customer-centric focus that you have?
Yeah, kind of like what Todd was saying, this connectivity, I think, is the key. I think we saw this early on as well on when bonded cellular came out. That kind of changed our industry on connectivity, changed our SNG systems tremendously. So I feel like this LEO has been a lot of talk, but it's very real now, and we're living in this time where we're going to see this come about, and it's going to change another level of change coming from what's going on.
Absolutely. So Sean, I mean, obviously you're very heavily involved in the mobility sector. Can you talk about some of the thinking there on these sort of multi-orbit solutions?
Yeah, so as a ground segment provider, we obviously are very much around open markets. And so we're talking to everyone from mobility providers to traditional kind of fixed infrastructure providers, services providers, and they all have a demand for multi-orbit solutions. Think about it from a mobility perspective. If you are sort of thinking aero, maritime, or even land mobility, you want the ability to really choose the right orbit and obviously the right service offerings to target those particular customers. At the same time, even our fixed customers. So if you think about a traditional telco, such as AT&T made an announcement recently that they were going to partner with OneWeb to offer an extension of their broadband service. we're seeing all of those options on the table. And essentially, these customers are looking to offer the best service at the best price to their customers. And sometimes that's LEO, sometimes it's GEO, sometimes that's MEO. We as a ground infrastructure provider have to support all of that and provide that in a seamless and integrated way so that customers can move between different orbits and different systems without impacting their quality of service and really that performance. And so, we don't really have a prioritization across any one vertical. We're seeing that need from our partners and our customers across verticals. And in many cases, they are either specifically building out their own, let's say, GEO and LEO networks, or they are partnering with people like OneWeb who already have a LEO network to deliver those type of services. And so again, that open network that we have in our platform is really the direction we're headed with from a ground infrastructure perspective.
Thanks. Yeah, I mean, let me come back to you a little on that. I mean, you talked about the price performance side of things. I mean, that's one of the areas it seems to me that there's often a debate about in the, when we're talking about new LEO systems is, is it about, and these new multi-orbit systems, is it really about finding the lowest cost of capacity? So does LEO need to be cheaper? Is it better? Is it because other people have said, well, LEO is a sort of overlay that can be a premium low latency service, and we'll fall back to GEO for the cheap bulk data delivery. So how do you think about that sort of the choices that people want to make? Is it different by segment? How do you think about that sort of relative lower cost premium versus premium service when you're pulling these sort of multi-orbit solutions together?
Yeah, I think it's a great question, right? So, I think you kind of hinted at this in your question. The reality is it is very much dependent upon the verticals that are being served. And what we're seeing is, obviously, when you're talking about some of the broadband opportunities that are very cost sensitive, that leads you to one direction in terms of how you go to market and how much interoperability and multi-orbit capabilities you provide in terminals. On the flip side, when you're looking at some of the higher end services where the customer really has a value add around multi-orbit, especially again around mobility type services, aero, maritime, and land mobility, there's less price sensitivity. And so we don't obviously dictate to the end user what those prices are. Our partners do that. But in terms of how they're looking at it and how we're looking at these markets, obviously there are different price sensitivities based on the use case. How much is the multi-orbit, low latency, higher throughput required versus having the ability to have a global network is dependent upon those verticals. And so we do have obviously a suite of modems that we target based on price point and performance. And when we talk about multi-orbit, so we do that today in the GEO space. When we talk about multi-orbit, we will have a portfolio of solutions that meet those price points based on different verticals and performance needs for very same reasons, except now there's more than one constellation to choose from versus before when we had just a GEO portfolio.
Yeah, and I guess the flip side of it is also on the terminal side. I mean, what do people want in terms of integration of these solutions? Are they prepared to pay a significant premium for terminals that function across these different orbits? Todd, let's come back to you. Do you want to talk a little bit about the necessity for integrated solutions from the terminal perspective? What sort of premiums are people prepared to pay for that versus relying on sort of multiple dispersed networks that you simply integrate separately and carry multiple terminals with you?
Yeah, it's a great question. Again, it's become harder. We were traditionally we just provided the terminal, and that now has even a different definition, right? You're adding in switching and networking components. You're adding in multiple modems. You have to add in, because if you don't do that, there's not the ability to switch between different architectures like we're talking. And that integration causes a lot of problems in heat and, just everything just keeps on compounding as we move down. But then the next thing that ends up happening is, and terminal providers are doing this now, right? We're incorporating other capabilities within the terminal. Can it attach to a cell phone system, right? It is great to have all these multiple orbits, but sometimes there's just trees there, right? There is no conductivity. So people are doing the other avenues off. So that's being built into the terminal. So terminals today are not what we would have traditionally thought of them being, and the turnover rate in that technology within the terminal is just as fast as that we see in networking and cell phones and everything and everything else. So it's becoming a very dynamic network. Things are having to be integrated more. In our pre-conversations, I said, here we're trying to think A to B from one person to the next person, and how do we optimize all that for all these various architectures? And so it's a different industry, which is driving a different price point, right? When you add in networking equipment, and you add in various modems, and you add in, cell phone radio heads into a traditional terminal, that cost is going up. And as this becomes more flexible, I think, it's very difficult because we have traditional, very expensive terminals all the way down to the new, cheaper ones, right? And it really does come down to what is the customer looking for capability that will drive the price point in that, market as we move forward, and understanding with that, advance in technology, what that's going to be.
Yeah, I mean, Darren, let's come to you. How much are your customers sort of moving budget, towards more complex and more sophisticated terminals, instead of spending it on the satellite capacity?
Yeah, that's a very good question. What we see as an antenna manufacturer, we normally sell to the integrators, so we don't get so involved in all of the details of networking. But we see the issues where our customers have all these different, like if they want it to work at GEO at 22,000 miles, or they want to work a few hundred miles, the amplifiers, the equipment that goes with that can be vastly different. And that's what we see as trying to solve a connectivity issue from the antenna side, trying to make something satisfy all the requirements gets a little challenging for the integration. And then if it's portable, like what we do, the portable terminal has got to come apart. It's got to all pack up, and then you've got to carry every piece with you. And then all the satellites themselves are not, they're all different frequencies. So LEO, MEO, that's a certain band. GEO, that's another band. So the equipment gets pretty involved when you're trying to have a simple solution for every application.
Yeah, and I guess that the question then becomes to what degree you integrate things after the after the terminal, and just have a Starlink terminal you feed into something, like you might have a cellular modem that you feed in to the network, and then basically optimize your routing of traffic based on the connections available to you at any one point. Now obviously that's not so applicable in a when you're talking about premium portable terminals where someone needs the smallest, most functional terminal possible. But the question that is in my mind is the degree to which, what share of the market is that really the applicable answer to? We've already seen, even on ships, for example, sort of a proliferation of different terminals that people would integrate separately, at a central comms box. And will that become the sort of default solution if it's too complicated to integrate at a terminal level? Todd, do you want to weigh in?
Yeah, I think this is very interesting, because traditionally SATCOM was for SATCOMers, right? Even if you wanted dish network at home, there was an installer that came in. In today's world, we've changed that dynamic. Starlink, you put up your terminal yourself. It does everything you need to do. It's more of a cell phone business model, right? You can run the thing. It's understandable. It's very, there's a GUI user interface. So is that, I think that's a part of what you're asking, would be my answer is, as that moves forward, right? It has to be more user-friendly, more layman, more things built in, like we're seeing, right? They want Bluetooth in it. They want Wi-Fi in it. They're going to want these things in that, because it becomes more of a user experience, where traditional, let's just be honest, right? We were kind of sat over our side, and it was just the part, right? A big dish out in the field or whatever it was. And a guy ran it or a girl ran it, whoever, came and did that. Today it's coming into the layman's market. And I think the answer is yes, they're going to want those features in there. Yes, we've got to become more integrated. Doing it the old way is just not going to work. And we're going to have to be turning over faster and making it a better product overall, right? And then, how does that move into the mass market? I think that's hard to understand right now because of the challenges Darren was just talking about. It's not an easy terminal to make to do all these architectures in multiple bands. And so I think there's an expectation coming out. And can we get the technology to match that expectation and do it in a really good business case? I think that's yet to be seen.
Yeah. Yeah, and Sean, I mean, obviously from a software perspective, there are other ways of addressing some of these problems as well, changing up the software depending on which network you want to use. Do you want to talk a little bit about some of the innovation that you're developing to help address these challenges?
Yeah, absolutely. I think Darren and Todd bring up some very good points, and so obviously there's kind of solutions at the terminal level that can be done. From a modem perspective, we are down the path of going towards a software-defined radio, where we're abstracting our software from the hardware so that for terminal integrators, they can truly have a generic hardware that can support multiple waveforms. So being able to support MEO, LEO, and GEO, and obviously using software abstraction to be able to load the version of software that is required, let's say for that particular constellation as an example. And so for us, this move towards software-defined radio gives us the flexibility to deliver this software in a way that is a lower cost ultimately for terminal manufacturers who are integrating multiple modems today, right? So instead of you having a dedicated LEO, GEO, or MEO modem, or potentially multiple GEO modems because you're using multiple waveforms to satisfy, whatever the need is by the end user, you have a generic, I'll say off the shelf, but a generic hardware modem that can load the various waveforms to support the various constellations as required. And I think that is another innovation that will take us a long way. The cellular market has gone that way a long time ago. You see that in the traditional wireline space a long time ago. We're going that direction in satellite. And once we get to that point, all of this multi-orbit capability will be even more achievable at a lower price and with a higher value to the customer. I think a lot of times we focus on price, and we do want to reduce cost because we want to reduce size, weight, and power, the whole swap scenario, especially with some of the Manpack and some of those type of mobility scenarios, land mobility. But at the same time, there's a lot of value in customers being able to seamlessly move across different constellations with just software changes and really interoperability. The other thing I'll mention, not to go too far, but is also around integration with 5G standards, right? And so by having interoperability from a satellite perspective to do handoffs into a 5G network, that seamless software integration also adds a lot of value and improves the overall customer experience. And I think as we improve the customer experience, there's a premium that we can also add to the market on top of that, in addition to lowering cost.
Yeah, well, with that, I mean, that is interesting. Questions just come in about whether people expect 5G equipment manufacturers to get into this business. And, you mentioned the integration with 5G. Let me take on that one slightly as well. I mean, my general feeling is that, as I said in the intro, the integration of the networks becomes really important of what you're doing on the satellite side and on the terminal side. And we've seen Starlink and Kuiper, put a lot of effort into developing their own terminals. I mean, even OneWeb in the early days, that was really where they were positioning it. We also, Greg Weiler come along and present his terminal at the satellite show and stuff like that. So, but the presumption behind a question about do 5G terminal manufacturers, start making this is that we get to volumes of many, many millions because, those people don't get out of bed for making a few thousand or a few tens of thousands of terminals, and that's sort of where we are in the rest of the industry. Yes, Starlink's got to 400,000 terminals. It looks like it's churning out 50,000 a month. That's perhaps enough to get STM or someone like that as a contract manufacturer to do stuff. But is the rest of the industry going to get to anything like that number? Are we still here making these things on a few hundred or a few thousand at most at a time? Darren, do you want to start?
Okay, yeah, I think, to some extent, in talking about 5G for like satellite technology, 5G actually causes interference on the satellite terminal. So we've tried to filter out 5G interference on our terminals. It's getting difficult to make everything mesh together because of that. But when you look at the consumer market, we don't know where that's going and how that's going to come about. I guess Elon and his global plans and the money that's behind that is going to change the world. For a small company just like us, we're always concerned that what we're working on is not going to be the right thing in the future. And it just doesn't take much for that. And I made the reference earlier. I'm always concerned that I'm working on a BlackBerry and somebody's working on the iPhone over here. It won't take much to turn that tide, and then you're just waiting to see. But from a small company point of view, we kind of get, I would say, pulled a direction from our customers. So we don't necessarily know what Sean is doing with the modem technology, all the networking, trying to solve all those issues. We don't see all that. So our difficulty comes in is when a customer calls us, say, well, we need to do this and we need to do that. And so we're always concerned that what we're working on is going to be acceptable. So our plans for product development have to do a lot with what feedback we can get from our customers, and are we doing something that is compatible? And that's there's a lot of standards that are out there that are missing in this whole connectivity issue, where in the past standards were developed on connectivity. Well, I think that's fixing to happen more now as all these different types of architecture come together. But we're hoping that if we can come up with a terminal that is flexible, that will allow certain things, and then not being an integrator, we would like to supply a terminal where an integrator can easily take what we're doing and make it mesh with their whole system. And that's the challenge for us. And then to say that it's going to be low cost, that's a challenge.
Yeah, absolutely. I mean, that I think is the thing we don't know. I mean, is it worth making millions of terminals? Sure, we've had the consumer market where Viasat and Hughes have made maybe 300,000 terminals a year. Now Elon's talking about making millions a year. And obviously there's a lot more cost reduction needed for those flat panel antennas to get them down to sensible prices. So it's an even bigger challenge and an even more difficult problem if we're talking about trying to compete with someone who's got massive volumes. So
and I would say on that front that over time, bandwidth has been our friend as technologies come about. Like the wireless industry, on your cell phone, you can do all kinds of things now that you couldn't used to do as technologies emerge on handling bandwidth. And we saw that with this bonded cellular. When bonded cellular came out, the satellite industry for like satellite news gathering changed immensely, because now they're doing all this emergency first responder stuff just using bonded cellular.
Mm-hmm.
Well, that was much cheaper at the time, but as things emerged later, they run out of bandwidth. So they come back and say, we need bandwidth. So satellite offers a lot of bandwidth in comparison to some of these other wireless features. So I've always viewed bandwidth as technology improves across things, that bandwidth is going to be in more demand, and that's definitely kept the satellite communications in business.
Right. Well, I mean, thinking about that sort of, those sort of volumes that Starlink are generating already, and Kuiper may, generate in the future. OneWeb and Telesat, I guess, have taken a somewhat different approach. They, as has O3b mPOWER. They're going to vendors who are in the satellite industry already, getting them to build terminals, compete, having multiple vendors compete to provide solutions for, sometimes, providing the same solution, other times providing solutions for particular niche areas like, aeronautical or maritime or whatever. Sean, do you want to tackle that question of, like, going outside, and going to the traditional markets? Is that going to prove sufficient to keep pace with what Starlink and potentially Kuiper are up to?
I think so, right? And I think this goes back to what I mentioned earlier, and we're kind of talking about it, right? What are the verticals that you're trying to serve with the technology? And it's not a one size fits all approach, right? And so you look at Starlink, when you think about some of the broadband opportunities and verticals that are being targeted there, those requirements are completely different than what you need for an aerospace or a global maritime type network, as an example. And so what we find is our partners and our customers are looking for truly multi-orbit, but then also multi-platform, multi-waveform solutions, so they can optimize it for the use cases they're serving. So they're serving, not just aero, but they're serving maritime, and they're serving enterprise and cellular backhaul markets. And so they need solutions that have the ability to span across all those different verticals. And a lot of times that requires you to have an open system. That requires you to be able to work with standards like the 5G standard, or standards like the Metro Ethernet 4 and Presto interface, to do the orchestration across different networks, to make that more seamless and to make it more manageable, even as an operator, to manage. I think, again, if you're vertically integrated and you have unlimited funds, let's say, you might say, my strategy is first to market strategy. And because I'm very targeted in one vertical, I can optimize my entire solution from the satellite down to the modem based on that one vertical. But most of our customers in the satellite space are multi-service providers, and therefore they have to look at the overall requirements, maybe not these niche requirements. And that does require them to have more of an open network where they are choosing kind of the best of breed to meet those requirements. It could be requirements around speed and throughput, I think, like Darren was talking about. Some cases around latency, some cases is around coverage, right? Having global coverage. If you are operating an aero network and you're switching between beams pretty frequently, things like beam switching times and some of that technology that you might not inherently get in a broadband focused satellite LEO offering alone might not be applicable. And so again, I think we try to look at what that broad scope is, what that broader need is, and then work with our partners to optimize our solutions around those multi-service offerings. And standardization is a very big part of it. I mentioned 5G, the TM forum from an orchestration perspective, MEF from an orchestration perspective plays a big role in that. And then also, like I mentioned earlier, our push and the market's push towards a software-defined radio helps to make that achievable.
Right. Yeah. One question that's come in that sort of tees off that is, and I'll come to Todd next. Does the connectivity demand, the volumes and patterns that you see from your customers, actually justify all this scaling up in NGSO, or all these new systems? Are they going to survive? Do the customers need all of these different new solutions?
Yeah, I think it goes back to what Sean just said. You do, right? And I'll give an analogy. We have, roads, but we have how many different models of cars out right there that can solve different requirements, right? I don't think that any one shoe fits all, right? I think that different architectures have, and this comes back from my government days, different architectures have different things that they're better at doing, right? If I want backhaul, I can go to Geo. If I want something that's, very diverse to do a little bit better in COTM, it just depends. Am I open ocean? Am I urban? Am I, and all that changes. And it goes back to what Sean was just talking about. And so you've got to have that variation. That variation will define a variation in terminals that can do that. That's why we have trucks, pickup trucks, cars, electronic vehicle, electric vehicles. That's why we have all this. And we have different roads. You have backcountry roads, you have big highways, that's how I would equate this, right? And I guess that's the best way to answer this that I have. Just go out and look outside and you'll see that answer, right? There's that variation. There's that different way of doing everything. There's no one way. If you're looking for a golden egg in terminals or in architecture, you're not going to find it yet.
Yeah, and maybe I shouldn't say that a lot of car manufacturers have gone bust over the years and been bailed out by governments, and so that's sort of one of the dynamics here is the geopolitical element to this, and I think the successful systems will require backing from national governments or regional players like the EU, and we're still to see a lot more new plans come up here in the space over the next few years.
And just to
Tim,
add to that real quick, Tim,
okay.
we talked about this before and Sean's brought it up, right? He's trying to make a digital modem. I think the governments do play, if you want everybody to be able to cross-purpose everything we're talking about, there are consortiums that have started up in our industry, right, that are trying to get digital interfaces, waveforms, etc., that will allow that to happen easier. So I think you're absolutely right. One thing that I really like is that the industry is trying to take care of itself right now, right? We've set up some own working groups within us without the government or with the government. But I think those are key things to allow exactly what we've been talking about to occur.
Yeah, I mean, go on, Sean. Yeah.
Yeah, just to add to that, to Todd's point, the DIFI consortium, we're part of that, right, around digitizing that interface. Our expectation, and the reality is we're seeing that growth now. I think you mentioned scale, Tim, and we're seeing the scale of our networks today, where we were selling. You had maritime networks that were a few hundred, maybe 1,000 terminals. There are now tens of thousands of terminals in a maritime network, thousands of aero planes now in an aero network. And so that scale is continuing to grow just in our geo space. When you add LEO or MEO into that mix in terms of new service offerings, we expect that scalability to only grow. And so we've seen tremendous growth in our gateways and our hubs deployments, but then obviously we're seeing that in terms of terminal growth. And in order to manage all of that, we have to start looking at standardization to be able to do this in a more economical way. At the same time, we're also working on network virtualization. So taking our entire infrastructure and virtualizing it so that it can be run in both a private or a public cloud. And we have solutions today that operate in private and public clouds, and we're going to extend that even further. If you think about a network management system, an NMS, running in the cloud and allowing customers to scale up their resources, their memory, their storage, as they grow their network, or even processing, right? Moving things into a centralized data center versus having all the processing in each gateway. With some of the new constellations, you have more gateways, ground stations, terminals, teleports than we would have in a traditional geo network. And so you can't replicate all that processing at each individual ground station. You have to now centralize that and then look at moving that into either private or public cloud as an example. And so that, to me, the technology also drives the scale along with customer usage and customer demand.
Yeah, absolutely. So Darren, you mentioned before about the sort of challenges of interference from terrestrial 5G. Well, one of the questions that we've received is about potential interference between GEO and NGSO when there's so many satellites in the sky. To what degree is orbital congestion going to be a problem for interference in the future?
Yeah, we see that as a great concern as well. We're still waiting to see, because on the GEO system where everybody, I think, is real familiar with the standards and the specifications that you have to meet so that you don't interfere with the guy next to you. So they're all on the geostationary arc, and you have satellites every 2 degrees, actually more than that, but they're all spaced out there. And now you have all these low Earth orbit, medium Earth orbits within that, flying all through there. The thing that has been one element of convenience is the polarization. The geos being linear polarized sometimes. That would be much more complex if that was the case on the LEO. So the LEOs, that's one way. Polarization discrimination is one way, but also the frequency bands are another way. So I think too, on the geostationary satellites where you're concerned about adjacent satellite interference, that may not be the same problem that we see with LEO, since they're all spaced out and moving. That issue is to do with more of things flying around in front of each other, and how do you deal with that and the different frequencies. So what we see on that is the interference is managed by polarization and frequency, but what is that really going to do when everything is, you have how many satellites are there going to be up there? I mean, I don't know that I would want to ride in one of these Elon Musk things or Blue Origin and go try to make it through there without getting hit. But that's one of those things that we're waiting to see how that really pans out. But right now we see it's from frequency and polarization is the main ways that interference is managed.
Yeah, absolutely. So Sean, let me come back to you. I think you just mentioned in your previous answer about the sort of virtualization and the need for edge processing. There's been a lot of talk about sort of the gateway as a service type concept, the integration with cloud services. We've heard a lot of people talk about Microsoft and partnering with O3B. A lot of speculation about what Amazon might do given its cloud position and what Kuiper might mean for that. Do you want to talk a little bit about that sort of the sort of optimizing performance there and what the sort of trade-offs there are for a satellite operator that has to think about outsourcing some of this and relying on these new sort of outsourced gateway as a service and things like that?
Yeah, absolutely. I mean, this is an area where we're spending a lot of time in today. We've announced some partnerships recently to do some proof of concepts in this arena. The reality is when we look at if you take our whole ground infrastructure, modems, NMS, protocol processing, and baseband processing, each of those 4 areas, we have activities today to virtualize those functions. And there are some trade-offs, though, right? And so when we look at this, think about the backhaul between a centralized location for your processing versus the gateway, right? You might have to have a larger WAN link to send those packets back. By working with partners, Microsoft or Azure as an example, AWS, who have the ability now to have cloud processing at these gateways and doing a handoff at the gateway, you now reduce some of that backhaul that's currently required today, as an example. We mentioned the Diffie standard. There's a few other consortiums we're in. We're trying to find those interfaces so that there's a kind of a streamlined, reliable handoff between our traditional satellite network and your traditional IP network for processing, as an example. The reality, though, is within the architecture itself, there's some high dependency in terms of speed and kind of processing capabilities that the cloud also has to catch up with, right? And so that's why we're doing some of these POCs, is to make sure that as we look at moving certain functions into the cloud, we don't impact performance, and that we do it in a way that is still efficient in terms of backhauling that traffic. There's some areas where, again, the network management system, where we've already taken that step. We have one of our network management systems running in a public cloud today. And we have our first customer who has purchased that as an example that will allow us to kind of change the way in which people consume solutions. So instead of you purchasing appliances upfront, paying all that CapEx money, they can now move to more of an OpEx model that tracks their revenue growth. So you build in the cost from a managed service perspective. You mentioned gateway as a service. You build the capacity, you buy the capacity you need as you grow. And so instead of you building for the next 10 years, you buy what you need for the next 1 or 2 years. And as you continue to grow in terms of customer and speed and requirements like that, you then scale up your service and your gateway as a service kind of solution from us. And so for us, we see this as where the market's going. You see this in the telco space. You look at companies like Cisco, you look at companies like Juniper, they've all changed their business model from more of this CapEx model to OpEx. And for us, network virtualization is core to that transition. And we believe by changing the way in which you go to market, and again, kind of this having resources on demand model, it allows us to have a bigger space because now more people can go to market without needing as much capital up front.
Great. Yes. And you know what, all of this new investment is also going to lead to a reduced cost of capacity. There's going to be a lot more services opening up. There's a lot of talk, for example, about telcos becoming more involved in the satellite space and being a bigger source of demand, more so perhaps than the specialist providers that have dominated it in previous years. Todd, do you want to talk about what you see these new lower cost capacity and more diverse array of sources of capacity opening up in terms of new markets?
Yeah, I mean, it's almost like we're in the revolution now where we saw the cell phone first coming out, right? The old backpack system, and then we had to realize what it was, and now it's pretty dominant in our society and everything that we're doing, and it's opened up a lot of markets. I think there's, for us, we're one market, the United States, but the global market, you brought up Greg Weiler earlier when he did O3B, the other 3 billion people started OneWeb. We now have Starlink. When that now becomes global, I think you're going to see a lot of different technologies emerging that will help the business case, right? And what do I mean by that? I mean, we talked about this before a little bit, we were talking about terminals being integrated, this evolving market will push chip development. It will push virtualization like Sean's been talking about. It'll push digital signaling within my terminals is what we're looking at now. And so that'll bring costs down, but allow that market to keep on expanding and becoming cheaper, like we've been saying over and over again, really in this whole discussion. So I think it's an interesting market. It'll keep on expanding. I think outside of the US and some places that have been underserved is going to be very interesting, but there's a lot of challenges there because Sean's already talked about, you've got to get that information out, right? It's more of an integrated circuit. There's more landing zones, there's more teleports, there's more backhaul, right? So there's a lot of integration that has to go on when you just say, all right, I'm bringing in a LEO, right? There's really about 15 times more landing stations just in the United States from one LEO than there is from a GEO, right? You can get away with a GEO, a couple in a hemisphere. In a LEO, it's, tens per country. And you got to backhaul that, and then you got to virtualize that, and then you got to have the terminals for that. So in some of the other countries, where infrastructure isn't there to even run the fiber, do the backhauling, I think it's going to be an emerging market, but I think it'll be, I think as that emerges, it'll drive more to even bring the cost down and the terminal cost down. So I think everything is kind of together in that market.
Well, yeah, I mean that raises the question then, as we talked about before, the sort of volumes here, the degree to which providers have to be prepared to scale up and are capable of scaling up in competition with someone who tries to do it all themselves and is vertically integrated. It's going to be a big challenge, and it's not clear to me, at least, how all of that sort of scaling up is going to happen easily for the traditional satellite industry. There's a huge transformation here that is not, I think, people haven't really figured out how to tackle.
Well, we We typically, let's be honest, Tim, in the satellite industry, we've been very, and Darren brought this up before, right? We are very segmented in what we do. I provide amplifiers, I provide LMBs, I provide modems, I provide terminals. I give you the backhaul, right? I'm the teleport and I give you the fiber on the backhaul. That has to change. We have to be more integrated in talking to each other. Partnerships are the key to this, right? Yeah, we are working within my company. I know we are working diligently to work with everyone that we can, because we see that dynamic is gone. That boat is sailed. And if we don't start working with our partners, you're not going to get an integrated terminal. You're not going to get it lower cost. You're not going to give more capabilities. It is not going to happen. Not one company has the ability to do all that. And if you do, well, then you're one of the big ones, right? You're not a small little guy like we are. And Darren is, you're a big company who's acquired many different divisions that can do that. And so, yeah, I think that's something that's going to happen. It's a dynamic that has to change.
Right, and it may be through partnerships for a lot of companies. It may also be other people having to get bigger and acquire all these capabilities themselves to compete. I mean, that's the other side of it. Sean, obviously you've had consolidation with new tech in recent years. I mean, what's next in terms of needing to get bigger, to keep competing, to keep advancing in this higher volume industry going forward?
I think the core of this is really around technology and standards. And so one of the things that we have completely embraced are the telco standards that are already there today. So instead of us building a new satellite standard around data processing or around orchestration, our approach has been very much around supporting these standards. If you look at scale, volume, specifically managing networks where there's hundreds of thousands of terminals, that is a solution, or that is a challenge that's already been solved in telco networks, right? Or in cloud type companies. You look at technologies like Kafka, using data lakes as an example, as a way of managing all that big data. We're adopting those technologies in our products today from an NMS perspective, as an example. If you look at being able to manage the orchestration of services across disparate networks from telco to telco, using things like the Metro Ethernet form, Presto interface, or the standardization of a carrier Ethernet service with MEF 3.0, all of those standards are things that we have already delivered, or we're in the process of building to deliver in our system, so that you can scale it without necessarily having to come up with something bespoke just for satellite. And so to me and to our company, the adoption of telco standards, whether it's technology or just standard interfaces and process, is crucial for us to continue to be able to scale without having to build all of that organically, or maybe having to purchase all that, let's say, or organically.
Yeah, I mean, there's sort of chime to one of the questions that's come in about, are we going to see a lot more vertical integration in the industry? Darren, let's come to you. I mean, how much does that scare you as a smaller player, or does that feel like something that's inevitable and something you have to live with?
Right. It's kind of like what Todd was saying. I really liked what he was saying. We've tried to manage that with partnerships, just like Todd was saying, is that we're a small company. So it's good that even earlier when we talked about the diversity required, or just what naturally happens with all the different options for connectivity out there, it just kind of drives a lot of innovation in a lot of different areas. And that alone kind of funds or pushes this technology across not just a huge player like one company, but a bunch of other companies have their niche. And so those niches will fit in with someone that they partner with. So I feel like, that kind of innovation does fit with, the partnering where, somebody comes up with a solution that solves a certain problem and they get really good at it. Well, somebody else will come up with something else. Well, maybe that's the way the industry goes. It's not one shoe fits all. It's very diverse. And I feel like that's kind of how we've survived in the industry that we have. We've had key customers we partner with. I mean, our probably one of our core products that has paid all our bills was just annual portable man pack flyaway unmotorized, about as simple as you can make it. You set it up, you point it to a geo satellite, and it just sits there. There's very low cost associated with this. It's low warranty, low operating for an integrator to buy that. So that has its niche, but that's not going to work on a Leo Mio. So the Leo Mio drives a whole nother scenario, whole nother customer base. And so we feel like if a small company is going to survive in that area, we've got to partner with someone, because we don't have all the hardware to do that. And especially when it comes to the networking, the modems, all the connectivity that we don't see what's going on past the ground terminal. There's a whole lot happening there, and that's where our partners are going to provide that. So we hope for the future that we make good decisions on how to break that up and become a niche in that area to survive. And if we don't, I think it'll be like Todd said, it's going to be a vertically integrated solution, and it's going to be hard for the little guys.
Yeah, absolutely. And Sean, let me come back to you. You talked about the standardization. I mean, I think one of the things that's always been interesting to me is this sort of dynamic of where the industry takes satellite optimized solutions and tries to make them a standard versus taking terrestrial standards and trying to adapt them for satellite. I mean, that's certainly, one of the conflicts we have with the LEO in the LEO space at the moment, that, a lot of those really taken LTE standards and adapted those to satellite in the geo world, we've had, as I say, satellite standards that have become a bit more standardized. We've had other people try and take cable modem standards or whatever and try and make them satellite oriented. So does that change in 5G? Do we have something that is, terrestrial that's adapted to satellite? Do we bring the satellite, optimized solutions into that 5G world? How do you think about that sort of dynamic of satellite optimization versus terrestrial adaptation?
Yep, great question. And this is one of those things where we are also kind of tracking and kind of doing a lot of research on. The reality is there are some unique, I'll say, physical dynamics with satellite that we have waveform technology like our MXDMA technology or ATMA technology that is optimized S2X, as you know, as a forward technology that's optimized for a satellite network, where we're looking at the 5GNR standard and looking at the advantages of that, and then looking, today, how's that perform in terms of efficiency for different use cases? What kind of throughputs can you achieve? The reality is, there is a period of time where we will still have satellite, let's say, specific technology in certain aspects of the network. And there is a point much sooner, though, that we see this interoperability with 5G and 3GPP standards being there sooner, right? So if you look at the interoperability, mobility, seamless mobility moving between networks, the 5G standard, 3GPP standards is perfect for that today. And we will adopt that in our systems as soon as possible. If you look at some areas like waveform, as an example, there are differences. And so we have to make sure that although we're looking at standardization, we don't do that at the impact of performance or efficiency in a satellite network. And so I think you're going to see a combination of both, not one or the other. And eventually, if the technologies kind of merge, that's actually ideal for everyone. That's great for everyone, but we don't want to, let's say, move too fast and then, at the expense of efficiency or throughput. I'll give you an example where, today we have the open EMIP standard in terms of ACU control, or the open BMIP standard in terms of buck control. I mean, those are unique solutions in the satellite space that I don't know if there's an equivalent type of standard today for telco. So we wouldn't change those type of standards, but there are definitely areas around your core mobility capability for 5G and 3GPP, where I believe we can accelerate that into our space as we look for some of the other more satellite-specific technology to mature.
Great. Well, it's been a really interesting debate. I think we're just about out of time now, and so we're going to wrap up. There are some questions that have come in that are specific to one panelist or specific technical questions that will be answered in written form after the webinar's over. Thank you very much to all our panelists today. It's been a really interesting discussion about what's a really fascinating time in this industry, and I think we could go on for hours here. But as I say, our time's running short, and so I'd just like to thank all the attendees for listening, and remind you that there will be another GVF webinar on June 30th on the geo value chain. It's been a very interesting series so far, and I'm sure that will continue. So thank you very much to all the panelists, and thank you to the attendees, and appreciate you coming.
Thank you.
Thank you. Yep.